Hi everybody, I am Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Next we could see the problem which is related with ideal gas equation and van der Waals gas equation. So first let us see the question. Calculate the pressure exerted by 1 mole of CO2 in a 1.32 decimeter cube vessel at 48 degrees Celsius using A. Ideal gas equation, B. Van der Waals gas equation. And this is the question. So what they are asking, what is the pressure produced, the pressure value produced. Okay, so we should know certain factors since they are asking using both the equations. When we go for van der Waals equation, we should know the constants of van der Waals constants A and B, what is the value, and when we are using both the gaseous laws, you should know the gas constant value R. So here A, the van der Waals gas constant A is equal to 3.59 decimeter cube atm mole power minus 2. The van der Waals constant B is equal to 0.0427 decimeter cube mole inverse. And gas constant R, here we are using 0.08206 decimeter cube atm Kelvin inverse mole inverse. So first let us solve the problem for ideal gas. We know ideal, for an ideal gas, we should know the ideal gas equation PV is equal to nRT, and the pressure is asked, so nRT by V, the problem will be nRT by V. So how many moles? 1 mole of carbon dioxide, so 1 mole. So N is number of moles, so 1 mole we have substituted. R is the gas constant 0.08206 decimeter cube atm Kelvin inverse mole inverse, that we have substituted here for gas constant R. And next temperature, for temperature we have 48 degrees Celsius, and the 48 degrees Celsius can be converted into Kelvin, so we have to add up with plus 273 or 273.15, then the answer will be Kelvin, we will get Kelvin. So 48 plus 273 will give us 321 Kelvin. So we have substituted for temperature. And what is the size of the vessel? It is 1.32 decimeter cube. So all the values and variables we are substituting here with units, along with the units. So we have substituted here, and when we go for simplification, here we have mole and here we have mole inverse, so both the units can be cancelled out. Here we have decimeter cube and here we have decimeter cube, both the units are cancelled out. Here we have Kelvin inverse and here we have Kelvin, both all the values are simplified. So here atm, so when we multiply the value of 1 into 0.08206 into 321, we will get a numeral value. When we divide that value by 1.32, we will get the answer as 19.95. Here we have atm, which is left behind, should be written with. So the pressure's unit here is 19.95. So this is the answer for the first part of this problem. Next, for the same question, we are solving with van der Waals gas. So we have rearranged the equation for pressure. So the equation is pressure is equal to nRT by V minus NBC minus N square A by V square. Okay, so this is the problem, and I hope you can be substituting the values. N is number of moles, so 1 mole of CO2 which is given in the problem. R gas constant value 0.08206 which is given again, that can be written, and nRT temperature is 48 degrees Celsius, and when we convert the value into Kelvin, we will be getting 321 Kelvin divided by volume is 1.32 decimeter cube minus N, how many moles? 1 mole. into what is the constant B constant, van der Waals constant 0.0427 decimeter cube mole inverse. So we have substitute the value in the first part, minus n square 1 mole square into 3.59 decimeter cube atm mole power minus 2. This is the constant value of van der Waals constant A is equal to 3.59, which you may be given with the problem, or we should take that, we should have that value. Okay. Then V square is 1.32 decimeter cube. Here, since it is V square, we will be getting the value into square. Clear? Okay, first we have to simplify the value of a numerator in the first part and the value of a denominator in the first part, and we will be getting the simplified form, the first part, that is nRT by V minus NB. First we have to simplify this one to get some value, minus we have to simplify this one, first the numerator of this one and denominator, then simplify, then the second part. So first part minus second part, then we will get the final value. Okay, so let us try the first one. Here we have the value mole inverse, Kelvin inverse. Clear? And in both the values, in both parts, we have decimeter cube. We can take the decimeter cube as a common one here. So we can write it as a common one, or we can simply write the cross out the decimeter cube in both the values. Since and 1 mole here, 1 mole inverse. So what is the value here, ATM, for all the terms? So we have 0.08206 into 321 divided by 1.32 minus 0.0427. If we simplify this one, we will get a value here. Okay, we will get a value, and here we have to multiply 0.08206 and into 321. So when we simplify the value what we have get here divided by the value, we will get the final value of this first part as around 20.62 ATM, around 20.62. Okay, so I will not say that accurately we will get this value, around 20.62. And now here we have mole square, mole power minus 2 here, and when it is square for both the numeral and decimeter cube. So 1.32 square and decimeter 3 into 2 dm power 6. So this dm will be cancelled out, and when we simplify 3.59 divided by 1.32 square, we will get the simplified answer as around 2.06 ATM. So we can take the ATM as a common one, and the answer will be around 18.56 ATM. So this is the pressure produced by 1 mole of carbon dioxide when we use van der Waals equation. Thank you. Now let us discuss the next problem. Calculate boil temperature Tb for carbon dioxide gas, assuming it as a van der Waals gas. So why there is a condition given here? So we have to think like that. If it is van der Waals gas, we should know the gas constant A and B for van der Waals gases. We have that value. and boil temperature. It is not boiling temperature, it is boil temperature. And we should know the formula. There is a relationship, TB is equal to A by BR. So what is boil temperature? The temperature at which a real gas obeys Boyle's law. The temperature at which a real gas obeys Boyle's law is known as boil temperature, and it is indicated with TB. Okay, so the temperature at which the actual gas, atmosphere gas, which obeys Boyle's law. And let us see the relationship, TB is equal to A by BR. And we have to substitute the gas constant. Since I have written the values in the previous problem, I did not repeat it. So we have to write the problem again, the value again. So 3.59, the gas constant value A. The gas constant value A, that is 3.59 decimeter power 6 atm mole power minus 2. And in the case of B value, B constant 0.0427 decimeter cube mole inverse, okay, into the gas constant R value 0.08206 decimeter cube atm Kelvin inverse and mole inverse. So we have to substitute all these values. First let us simplify the units. So here we have dm power 6, here we have dm power 3, here dm power 3. So dm a power 1 and a into a power 1 is equal to a power 2. So it can be simplified, both the values. And we have atm, we have here also atm, that can also be simplified. And mole power minus 2 here we have mole power minus 1, mole power minus 1. So both the values can be simplified. And the lone value K inverse, when it goes to the numerator, Kelvin inverse will become Kelvin. So when we multiply the values of 0.0427 into 0.08206, and when we divide the value 3.59 divided by the product of these two values, we will get the TB value, boil temperature. Boil temperature will be 1026 Kelvin. So this is the answer we have received when we solve this problem. Okay, thank you.